Continuing our journey now, we're going to continue with something called geometric sequences. And I know you're probably saying, well, whoa. Didn't we just talk about arithmetic sequences and series? Well, yeah. Well, if you remember what arithmetic means, that means that we were either adding or we were subtracting a common ratio every single time in order to get the next term. Well, look at this particular sequence I have right here. Well, there's 1, 3, 9, 27, 81. Well, if we do that common difference stuff, you'll notice right away to go from here to here is actually plus 2, but to go from here to here is suddenly plus 6. We're in trouble. It's not common anymore. But if you're really, really smart, take a look at this. This is 1, 3, 9, 27. I'm pretty sure you figured it out already. We're going from 1 to 3. We're actually multiplying by 3 because check it out. You're going to 3 to 9. Again, you're multiplying by 3. 9 to 27 is multiplied by 3. 27 to 81 multiplied by 3. Even if you can figure this one out, 81 to 243 is actually, again, multiplied by 3. So we don't have a common difference anymore. We actually have something called a common ratio. And what do I mean by that? Well, do you remember when we were talking about arithmetic, we would say take the term and subtract the term before it. So we'd go like 9 minus 3, it'd be 6, and that would be our common difference. But in this case, being that this is a ratio now, we take this term here, number 9, and divide by the number before it. So if you look, 9 divided by 3, in fact, is 3. You can do that with anything. Look, take 81 and divide it by 27. Right? 81 divided by 27 is in fact 3. You can even take 243, any term, divided by the term just before it, and you will get 3. So that's really, really important to understand. So now let's go and talk about what a geometric sequence actually is. Okay? Geometric sequence. It's a sequence. I wrote it down as a series here. It's actually a sequence, so it's separated by commas. It's separated by commas, and you can see the comma here, comma there, comma here, comma everywhere. There's a comma, there's a comma. Okay? It increases or decreases based on a common geometric ratio. Aha. And ratios are determined by dividing the term by its previous term, right? You take the 9 divided by its previous term, which would be 3. All the stuff that we talked about already. Now, how do we go about figuring out a few things? Well, wait. Look, common ratio gives you the whole definition here. There's that ratio formula, okay? But here's a couple of interesting things about the ratio. The ratio can actually be positive or negative, okay? For example, if you got a sequence that looks like this, well, take a number, divide it by the one before it, okay? 8 divided by 4 is 2. But what if I gave you a sequence that looked like this? 2, negative 4, 8, negative 16. Look what happens to the ratio. Look at this. We have alternating positive and negative numbers. Isn't that interesting? So take a number, okay, there's minus 16, right? Divided by the previous number, 8. That turns out to be a sequence, I should say a common ratio, of negative 2. So your ratios can either be positive or negative. All right, there must be a formula that goes along with this. Sure enough it is. It's right here. It's the formula Tn. So in other words, you can find any term. What you do, simple. Multiply it by your first term, and then multiply it by the ratio. But here's the important part, because think about it. As we went from ratio to ratio, we're not adding 3 anymore. We're multiplying by 3. Since we're multiplying by 3, we're dealing with exponents. So you take the ratio to the power of n, subtract 1. And remember, those n's, yep, they match. Okay, so lots of arm waving stuff, but no real practical example yet. Well, not until now. Here we go. Bonk. There's a nice little example. I wrote the formula here to make sure that you know and I know what it is. Okay, so here we go. First things first in this example right here. It says, find me the common ratio. Easy. Pick a number. Divide it by the number previous. Okay, common ratio is 3. We're going to call that R. R for common ratio. Just like in the last one, we said D was the common difference. Now we're saying R is our common ratio. And it says, find me the next two terms. Well, we did this already. Remember, times it by 3, that gave us 81. Times it by 3, that gives us 243, and so on. There's our next two terms. But now it says, what's the general formula for this? Well, simple. All you have to do is say, okay, here's Tn. T1, well, T1 in this case is 1, all right, times R, the ratio, of course, is 3 to the power of n minus 1. Awesome. Well, when we're multiplying by 1, that's not going to change anything. So our actual general formula is 3 to the power of n minus 1, which is kind of neat. Let's see if that actually works. Let's see if that actually works. Take the number 27, for example. Well, what term is the number 27? That's first term, second term, third term. That's got to be the fourth term. So being that that's the fourth term, check it out. We are now finding T4, and let's use this general formula. 3 to the power of, well, those 4's have to match, minus 1. And you'll see that this is 3 to the power of, well, 4 minus 1 is 3. 3 cubed, in fact, is 27, which is, woohoo, our answer right there. Look at how pretty that is. It's awesome. Let's do the same thing for B. Okay, so let's clean up this formula so I can actually see it again. Right there. Okay, now it's all cleaned up, ready to go. Okay, here we go. Last one. Figure out the common ratio first. Going from that to that, well, okay, minus 8 divided by the number previous tells you that that's a common ratio of -4. Give me a couple more terms. Well, you can multiply this by -4, which you know a negative times the negative in this case is actually going to be a positive. But you know what? Just to be safe, let's boot up our calculator. So bringing up our calculator here. Here we go. Okay. So I want -128 times our common ratio, which happens to be -4. So obviously this is going to give you a positive number. That's going to give you a positive 512. So there's our next term, which is a positive 512. And then again, we're going to multiply it by -4. So the nice thing is, by not clearing your calculator, you got that number in there. Just multiply it by the common ratio again, which ends up giving you -2048. Holy smokes, -2048. So one of the things that you're going to notice about a geometric is they increase really, really fast. Look how we went from 1, 2, 3, 4, 5. Our sixth term, T6, is actually a pretty big number. Holy smokes. Now, this one also asks us, don't forget, we have to find the general term for this. So there's where we pop in the formula. Tn equals to T1 times R to the n minus 1. Remember, these n's stay the same. Okay, so Tn, general formula, T1 is actually 2. And our ratio, which we found out to be -4. So let's put the -4 in brackets, to the power of n minus 1. Now, here's the biggest mistake people do all the time. They end up multiplying these two numbers. Well, you can't. You can't multiply them because of the simple fact that that is a 2, that is a 4, and this is to an exponent. So you can't multiply those numbers. Remember what BEDMAS told us. BEDMAS told us brackets and exponents first. After you've done the exponent, then you can do the multiplication. So what's the general formula? That's it right there. So stay tuned for some great upcoming questions.